Okay, let's talk about arrays. Variable syntax is pretty straightforward for arrays. Var keyword, then the name of your array, then the type. In Go, arrays are of type length plus their element type. I repeat, arrays are of type length and element type. What does that mean? That means you cannot set these two arrays equal to each other. Let me demonstrate that over here. Specifically, cannot use RB, which is of type 6int, as type 5int in assignment. Okay, good. If we want to initialize an array when we declare it, we use curly brackets and then a list of the elements. And let's print this out just to prove that it works. Of course, the equal sign should be over here. Of course, we can also use the colon shorthand to declare an array. And let's print it on the right. We can also be lazy and use ... instead of specifically enumerating what the length is going to be. This just means that Go will go ahead and count whatever we're passing in, and that will become the type length. And it still works. Now, a hugely important thing about Go arrays is that arrays are values. Let me say that again. Arrays are values. In C, an array is just a pointer to a chunk of memory. In Go, that is not the case. An array is a value. So what do I mean here? Let's say I do something like this. Let's set my first array equal to my second. They're of the same type, so this should work. Let's also print out their addresses in memory. We can use %p to get at that. And let's do a new line in between. Again, %p will just format the string so that we're displaying the value of the addresses in memory. And of course, I also have to dereference the variable so that the value being passed is the pointer value. And clean this up just a little bit more. So let's look at our output. The two arrays contain the same values. However, they exist at different locations in memory. That means then that when we set array A equal to array B, Go made a complete copy of array B in memory. So if we did something like change one of the elements of array A, only the value of array A would be changed. Array B, which is a completely different location in memory, would be unchanged. Again, this is completely different than C arrays, where arrays are just pointers to chunks of memory. If we were to do this in C, we would expect that the blocks of memory would be the same and that the third value of each pointer would be in lockstep.